We talked about frequency shift, and so we saw that is when your regular old sine graph changes from something like this to something like that, or to something like this, where the frequency changes, going higher or lower. Today, we're going to discuss, now, come back a second, frequency shift. There was a multiplier there inside the sine or the cosine. Today we're going to be looking at, that's Gagulus. What is going to happen if there's a plus or a minus on the inside there? All right, we call this a phase shift. Does anybody want to make a guess how that's going to affect the graph? Up, down, left, right, bigger, smaller? Anybody want to make a prediction?
Is it going to? Well, I would know because.
Well, we've already done up and down, right? That's the vertical shift by having a plus or a minus tacked onto the end. We've also, flip from like up here to down there and down there to up there. That's been a negative. We've done multiply or sort of expand vertically. That's when you've got a multiplier right there. That's going to be large amplitude, or if it's a small multiplier in front, small amplitude. And we've already done stretch out or expand or compress. That's a multiplier here. There's really only one option left. Anybody know what that is? Shifting left and right. Okay? But it's not always what it seems. All right? So you put your phone away, put your MacBooks away. Mason, come on up here. Mason, did you walk with me the other day? Who walked with me?
It was Hannah.
It was Hannah.
She kept leaving me.
Come on, Hannah. We're getting Hannah up here again. All right. Oh, pets off inside, ladies.
It's Western Day.
All right, I'll allow it. Okay, Michaela, make sure you get us in the picture here. Now, if you remember last time, for every one step that she did, I did 2 steps, right? And so go ahead and try it real quick. Rosa, call out the march number there.
Oh, okay.
We'll start in the same spot. Go ahead, call it as march. Call it out.
Taking one step.
You take 1 step, probably about the same. Like, try to make it my regular steps.
Okay.
Call it.
March.
So last time she was like, I was like 1, 2.
March.
1, 2.
So sad.
1, 2. So you see how I'm getting farther and farther away? We saw that happen. Okay, you can go back now. No, back now. Today, we're playing the game that, Hannah's smart, but I'm always 1 step ahead of her. Okay? So we're going to, I'm 1 step ahead of you, so you'll be back there. So, okay? So when she calls out march, we're both going to, in lockstep, take 1 step.
Take 1 step.
All right? Okay, if you can make your go down after you do the step, then it'll sound cool. Okay? Cool. Ready? Go ahead.
March. March.
All right, y'all get it?
Yeah.
All right, take a seat for 1 minute, and I'll play back up here in a second. All right? So you saw that we were marching along. I'm always 1 step ahead. Now, if we were to graph that, if we're thinking A, B, C, D, as we were marching along those spots, at time 0, she was at A. At time 1, she was at B. At time 2, she was at C. At time 3, she was at D, right? But what about me?
You started at 1.
I started, time 1, I was at B. I was already here.
Yes.
At time 1, I was at C. At time 2, I was already at D. You see this?
Close now.
So my graph kind of looked like that. Her graph sort of looked like that. That's really anyway. Now you might say, or if I were to ask you the question, what's the relationship between the red graph and the blue graph? You might say they are parallel.
Yeah.
How would you get from blue to red?
To get from blue to red,
You might think shift up, and it does kind of work here. But the way that I want you to think about it is this is like a shift to the left. So whatever her value was here, I was there earlier. See what I'm saying? Okay? Technically I was at A before her as well, so everything there would look like that. Okay? Now, the lines aren't the best ways because the left shift does kind of look like a vertical shift, but when we go around the circle, you'll see. So we're gonna go at, we'll go 45 increments. Alright? Yeah, she knows what to do here.
She's like,
So,
I'm ready.
I'm always gonna start one step ahead, so we're going 45 by 45s, okay? So, alright, Rosa. Oh, I'm right here.
March, 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 March,
I'm already around.
Looks like you're dancing.
Keep going.
March, March.
You see where I'm going? Okay, so let's see if we can do this. See if we can synchronize it. Ready? Set, go.
Oh wait.
So I'll say one Mississippi. So ready? And try to do one Mississippi rotation. Ready? And one Mississippi. I'm a little bit ahead of you. Okay. You get the idea. All right. Take a seat there. Good job. Take it easy. All right. So think about what that looked like here. We can say she started off at 0, you know, like a sine wave, something like that. But when she was right here at the origin, I was already, we'll do off by night, I was already up here at the top, you know, okay? And so, then when she was at the top, I was already, it was as if I was kind of like ahead, you know, and when she was up there at the top, I was already moving down like this had shifted there. And when she was at the bottom, and when she was back at 180 degrees, I was already ahead of her. I was already right here. And then when she was back down here at 270, I was already up. You see what I'm saying? It's like everything had been shifted to the left.
Yeah, it does.
Do y'all see how that works? How I'm always ahead of her. My graph is hitting the high point before hers. Mine's hitting the midpoint, the we call this the baseline before hers. You see how that's, if you think about this in time. Now think about what her graph would look like equation wise. That's just y equals sine of x. How would you describe my equation? Y equals sine of whatever her value is. I was always plus something, right? I was always plus. In our demonstration, it was pi over 4, but for this, in this case, I'm pi over 2 ahead of her. Okay? So x plus pi over 2. Let me say that again. Wherever she was, I'm ahead of her. I'm plus, right? But when we look at the graph, which way does that shift the graph?
Wait, you're talking about your red one?
Yeah, the red from the blue.
It shifts it to the left.
It does shift to the left. This is a little bit weird to our thinking.
That's why I was like,
It is, because when you see the plus, you naturally are going to think, oh, that's going to shift it to the right because plus is to the right, and plus is to the right, and more positive is to the right, just like more positive is normally up. However, when we're doing the graphs and the functions like this, the plus means essentially I'm getting to those spots earlier. So that results in a graph which is shifted to the left. This may have thrown you last year, if you remember in Algebra 2, when you would be graphing things, and there was a f of x plus k or f of x minus whatever. The plus and the minus was always different. It was always the opposite. If it was a plus, that was a left shift. If it was a minus, that was a right shift. Okay? Hopefully this kind of helps to explain to you why. It's because I'm hitting those same spots that she's going to hit there, but I'm hitting them earlier. And earlier means more to the left. So if we did have a minus there, that would correspond to a shift to the right. Sound good? All right, let's practice this. They don't call this a horizontal shift, they call it a phase shift. Put that phone up so that's So immediately skip number 1 and 2. Let me say that again. Just immediately skip number 1 and 2. Number 1 and 2 are terrible 1 and 2s.
Why do you keep doing this?
Because I feel like minus pi and plus pi over 2 are easier for you to process than minus 5 pi over 6 and plus 5 pi over 4. Am I right?
Yes, but why do you keep making the harder ones first?
I have no control over these
Oh, I
numbers.
see.
That's randomly generated, and if I am satisfied going here. Now, this does have an increased level of difficulty slightly because it's got the multiplier out here in the front, but we're experts in amplitude changes, so that's no big deal. All right. And with a light pencil, let us graph y equals 3 cosine x. And then we'll worry about the shift. So let's just go 3 cosine x. Baseline right there on the x-axis. Amplitude of 3 means I'm going to go up 3 and down 3 from my baseline. And then somebody remind me, where does cosine start? Cosine does not
Oh,
start at
cosine.
baseline.
Pi.
Cosine starts high. And where does cosine end? High. And in the middle? Low. Crosses the baseline at pi over 2 and at 3 pi over 2. We will connect that with a lightly sketched curve. Alright, looks like everybody's got that. Now, talk to me, class. We have x minus pi. Is that going to be a left shift or a right shift?
Right.
You are right.
Oh.
Right shift pi. So that means each one of these 5 dots is going to get shifted to the right pi, which, if we look here, 1, 2, 3, 4, happens to be 4 boxes. See that? Because that's pi right there. So I'll say 1, 2, 3, 4 boxes. Kind of goes that way. 1, 2, 3, 4. I might even start to kind of sketch it while I do, so I don't so I can keep track of which one I'm on. 1, 2, 3, 4. This dot right here is going to shift over 1, 2, 3, 4. And then if you want to, you can go back and lightly erase that original. There we go. When you're working on these problems on Alex, I'd recommend that you actually do the same process that we're doing right now. That is, plot your 5 points, hit the graph to make it to get your curve. Then go back to those 5 points and just shift them left, shift them right, and then you can actually go and erase your original function using the erase button. Erase those original 5 dots, and then you can hit the graph button and it'll graph these guys. That's it. Any questions? Let's do another one here. Number 4, graph function 3/2 sine of x plus 2. So let's go ahead and graph. What's 3/2 as a fraction? Anybody? 1.5. Let's graph 1.5 sine of x. Then we'll worry about the shift. 6.5, negative 1.5. Now remind me where the signs start.
Middle.
Start at the baseline. At 2 pi, where is it? Baseline. Right at pi. Baseline. First it goes high, then it goes low. And here we go. Now, somebody else tell me. We have x plus 2 on the inside. Is that going to be a left shift or a right shift? You are correct. Left shift pi over 2. So looking here at our tick marks, how many tick marks is pi over 2 going to be? Should be 2 tick marks. There's 4 of them that are pi, so yep, everything's getting shifted over 2 boxes. 1, 2.
Wait, how can you tell how many to move them over?
Okay, so pi over 2 is half of pi. Pi right here is 4 boxes.
Oh, okay.
And so, therefore, pi over 2 is right in the middle. So that's 2 boxes. That gets shifted over 2. This gets shifted over 2. Over 2. And that one gets shifted over 2. So here's something that's kind of neat. What does that red graph look like to y'all that are observant? Let me.
Cosine.
Yeah, I'm gonna erase this first part. Yeah, it looks like cosine.
Oh, whoa.
Notice that?
Wow, dude.
Yep. Sine and cosine are exactly 90 degrees out of phase.
Trippy.
Cosine is, and I mean for that matter, secant and cosecant are also 90 degrees out of phase. They're just shifted. If you remember, I mentioned that. They're shifted a little bit. So there we go. Questions on number 4? Alright, now we can go back to number 1 and 2. This isn't too bad because they've got an amplitude of 1 right there. So I'll just go ahead and draw my standard cosine graph. Lightly, of course. Baseline, top line. And cosine begins high, ends high. In the middle it's low. And then baseline, now this is going to figure out how many tick boxes there. 1, 2, 3, 4, 5, 6. Okay, so 1, 2, 3. 1, 2, 3. It'd be tricky to graph a cosine. That's to graph a cosine between the lines. It's tricky, but not too tricky. All right. Inside the parentheses, we have cosine of x minus 5 pi over 6. Class, is that going to be a left shift or a right shift? You are right. Five pi over 6. How the heck are we going to figure out what that is? Well, what if it was just pi, like 1 pi, or 6 over 6. Let's see what pi. It turns out, Alex is real nice to us. There are 6 boxes here in between 0 and pi. So that means that each one of those boxes is 1/6 of pi. So 5, 6 pi, or 5 pi over 6 would be 5 boxes. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to start sketching this so I can keep track here. 1, go. Not too bad. Okay. Glancing at number 2, class, would that be a left shift or a right shift on number 2? You are correct. And what's more, if you look at it, there's 4 boxes between 0 and 5. Now this says 5 pi over 4. So how many boxes would that be? It would not be 6 boxes. It's 5/4, and each one of those is 1/4. So this would it would be 5 boxes. 5 boxes left. We're not going to worry about that one. I want to give you a little bit of time to get some problems done. Before I do, rapid up today, we talked about a phase shift. Okay, left to right, always 1 step ahead or 1 step behind. You know, depending on which way you look at it. Michaela, you can go and cut it. I want to have a just quick class discussion. So we brought this up